Welcome to Maths for You channel. Now the past question and combination statistics. Part of past question. A committee of 6 members has to be selected from among the members of 2 groups, each having 3 boys and 2 girls. So identical group, 3 boys and 2 girls, such that the number of girls in the committee is at most 2. So the maximum numbers of girls in the committee must be 2 or is 0, 1 or 2. Find the number of different such committees that can be formed if part 1, even numbers of members from each group are to be selected for the committee. And then the second part, only one girl is to be selected for the committee. We just stick with the first part. Prior to doing the first part and tackle with the question, this is more of a wording question in statistics. So the best to get all the data in a format, table format or table distribution, and write down as much as we can to give us visibility to tackle the question. So the first one is 6 members group or 6 members committee. And we have 2 groups, G1 and G2. I just named it G1 and G2. Both are identical because both got 3 boys and 2 girls. So 3 boys, 2 girls, group 1, 3 boys, 2 girls, group 2. And again, condition in our the main part of the question is the maximum 2 girls in the committee. So it could be 2 girls or 1 girl or no girls at all. So the maximum, the number of girls should not exceed 2. Even number of groups. So the first part, even number of group from group. Sorry, even members from the group. We have a 6-member group, and if you are selecting even numbers from group 1, group 2, so there are 2 possibilities, 2 and 4 or 4 and 2, no other combination we can think of. Right, so just 2, 4. Let's look at 2, 4. That's number 1 selection, 2 and 4. 2 members from group 1, 4 members from group 2. So the 2 members from group 1 can be 2 boys, no girls, or 1 boy, 1 girl, or 2 girls. If we do get 2 girls, just to explain why I haven't actually got it here. If we do get 2 girls and no boys from group 1, and we can only have maximum of 2 girls. So we cannot make 4 members from group 2 because of all 4 have to be boys because there's already 2 girls on this group. So 4, we haven't got 4 boys in group 2, only 3 boys. Therefore, that's not possible. So only possible from group 1, 2 members, either 2 boys and no girls or 1 boy and 1 girl. Let's start with 1A, that 2 boys. 2 boys and no girls. And the group 2, of course, we can get 2 number of 4 members for them. It can be 3 boys and 1 girl, or 2 boys and 2 girls. 2 boys and 2 girls. So they're not other way because we haven't got 1 boy and 3 girls. We only got 2 girls. So these are the 2. And then the next one, 1B, I just said 2. So as I said, 1 boy and 1 girl. So if I do get 1 boy and 1 girl from group 1, and then of course 3 boys, 3 boys from group 2 and 1 girl. Because we need 4 members, we can get 2 girls, but if we do 2 girls, we already got 1 girl. So it has to be 1 girl from that because of only 3 boys we have. So only possibility we have 3 boys and 1 girl from group 2. So having decided the combination that we're going to get, and we put that little table or distribution now working out. So let's start with the 1A, 2 boys and no girls, and the other side, the first selection, 3 boys and 1 girl. So 2 boys and out of 3 boys, therefore the combination 3C2. And again, 3 boys out of 3 boys, the combination 3C3. And then again, 1 girl, so 2 out of 1, 2C1. So if you could work it out, 3C2 times 3C3 times 2C1. That's one equation. And the next one, next choice, again 2 boys from the group 2 and 2 girls. So 2 boys, 3 out of 2, 3C2, and 2 boys, again 3 out of 2, and 2 girls, 2 out of 2, the combination. So if we could write that equation, 3C2 times 3C2 times 2C2, second equation. Let's look at 1B, the 1 boy and 1 girl combination from group 1. So 1 boy, so out of 3 boys, so 3C1, 1 girl out of 2 girls, 2C1, and 3 boys out of 3 boys, so 3C3, and 1 girl from 2 girls, so 2C1. If we could get that in the form, 3C1 times 2C1 times 3C3 times 2C1 is the third equation. So these are the 3 combination or 3 way of doing it with the condition we have been given, 2 girls maximum, and then even numbers from each group, and also, so we just from the table we worked out equation 1, 2, 3. Let's simplify these equation 1, 2, 3. Equation 1. So if you look at it, 3C2 factorial, 3 factorial over 2 factorial times 1 factorial, 3C3, 3 factorial over 3 factorial times 0 factorial, and 2C1, that's 2 factorial divided by 1 factorial, 1 factorial. So the first one is 3, second one is 1, third one is 2, 3 times 1 times 2 is 6. The number 2, equation number 2, 3C2, 3 factorial divided by 2 factorial, 1 factorial, 3C2, 3 factorial, 2 factorial, 1 factorial, and 2C2 is 2 factorial, 2 factorial, 0 factorial. The first one is 3, the second one is 3, the third one is 1. 3 times 3 times 1 is 9. And the last number 3 equation, 3C1 for 3 factorial, 1 factorial, 2 factorial, 2C1, 2 factorial, 1 factorial, 1 factorial, and 3C3, 3 factorial, divided by 3 factorial, 0 factorial, and 2C1 divided by 1 factorial, 1 factorial. The students should know 0 factorial is 1, and 1 factorial is 1, 2. Okay, and then the first one is 3, second one is 2, third one is 1, fourth one is 2. So 3 times 2 times 1 times 2 is 3 times 2 is 6 times 2 is 12. So that these 3 combination of selection or 3 way of selection, and we have found the number of way we can select the committee or make the committee. The first one, 6 way of doing it, 9 and 12. So if we could add them together, we have is 1, 2, 3, add them together, 6 plus 9 plus 12 is 27. This is, we actually take 2 from first group, then 4 from second group. Then if you do that, the other number 2, if you look at it, number 2 here, 4 and 2. But it's the same identical, if you look at it, it's group 2 and group 1. This equation 1, 2, 3 will reappear. Therefore, it's because of identical 3 boys and 2 girls, and the group 1 and 2 is no other way, no different to group 1 and 2, 2 and 4, and 4 and 2 the same. So it should be another 27 because of 2 is identical to 1. Therefore, total committees 27 times 2 is 54. Okay, that's first part done. The second part, let's read it again. The second part says only one girl to be selected from for the committee. So one girl and five boys. That is so simple. From the two group, it's one girl. So easier straight away. We have both groups G1 and G2. So it's not that we have to take one or two or one from one group. It's not condition, but it's 6 members, one girl. That's all. The second part, 6 members, one maximum number of girls. So there's 5 boys, 5 girls. Two group. We can actually combine two group as G1 and G2. Now the big group will be 6 boys and 4 girls. 6 boys and 4 girls. Out of that, we need to get 5 boys and 1 girl. That's the condition. So as I said, group 1 and 2 is 6 boys and 4 girls. Number of committees we can get is simply 5 boys out of 6. So 6C5, the combination is 6C5. And again, 1 girl out of 4 girls, so 4C1. Simply that 6 factorial divided by 5 factorial, 1 factorial times 4 factorial divided by 1 factorial, 3 factorial. So 6 factorial divided by 5 factorial will be 6. You can work it out. It's so simple. And again, 4 factorial, again, just 4. As 4 times, or 6 times 4 is 24. The second selection or the second condition to select the committee, and number of ways to select it, 24. Thank you. Please subscribe the channel and share the contents with fellow students. Thank you.